Welcome to Math Academy, learning how to deal with Shrog and Grady. Yeah, hey, it's everyday math equations in my brain. Yeah.
Welcome to another edition of CMA 8th Grade Math Academy. We'll start out today, like always, with our learning goals. So we've been doing a lot with solving equations, writing equations from word problems, and now we're kind of stepping into the next part of that. What will we be learning today? Students will write a system of equations. System of equations is a new word for us, but that really just means more than one equation. So multiple equations, and we are going to graph those equations and then use those graphs to solve and make sense of the problems. Okay, so that seems like it's new and stuff that we don't know how to do, but we're really just taking what we know how to do with one equation and now doing it with multiple equations. Okay? Why are we doing this? Well, until now, we only have a way to solve equations that have one variable. If we have an x and a y, we can't solve for both x and a y. But this will allow us to be able to solve for more than one variable at a time. So if we have two equations and they both have an x and a y variable, we can now solve to find both x and y. We haven't been able to do that to this point. Okay? How will you know you've been successful? When you are given a word problem or a situation, you'll be able to write two equations from that, graph them, and solve for those two variables. All right, let's get started. We will be starting off on page M348, the Getting Started section. I'll give you a second to get there if you're not already there. All right, we've got a paragraph to read, so I'm going to read it, but as always, you need to be following along, and when I pause, fill in the blank, okay? So it says, your school's parent-teacher organization wants to sell sleeve t-shirts as a fundraiser. The business manager found a company that will charge for each long sleeve t-shirt and a setup fee to create the design that will be placed on each shirt. The chairman of the fundraising committee suggests selling the long sleeve t-shirts for each. The organization has asked you to help them analyze the product's cost and the amount of money that can be made by this. All right. So it says, number one says, if the shirts are sold for $8 each, which it told us in the paragraph above, at what point will the parent-teacher organization start making a profit? Show your work. Describe the reasoning you used to determine the answer. Okay? So at this point, I'm not going to give you many instructions or any hints or anything. I just want you to try and solve this. Okay? So try to find when the organization will start making a profit. I'm just going to give you a couple minutes to work, and then we're going to go on and find out ways to solve this. Okay, so I know that probably was not enough time for most of you, okay, to get that done. And that's all right. The point I wanted here was that you kind of started working and just thinking about possible ways you could solve this, okay? Because in this unit, we're going to find some easier ways, hopefully, some fast ways of solving problems like this. And I'm guessing in that 2 minutes, you guys didn't have a chance to actually come up with an answer, okay? If you did, that's awesome. If not, don't worry. We're going to find our solution to this, and we'll come back and figure this one out using some easier methods, okay? So let's move on to the next page, which is page M249. All right, so here we have the same setup that we just read through, okay? We've still got shirts that we're trying to sell, $160 setup fee, $4 each is the cost, and we're selling them for $8. Okay, so question 1 says, write an equation to represent the cost. The cost is key here, okay? So we're trying to find how much it's going to cost us for these shirts, and we're going to write an equation. And it says to define your variables, okay? So we know from writing equations, and when we've done stuff like this before, when we're writing a cost function or a cost equation, we're going to have two variables. We're going to have our total cost, and then we're going to have our amount of products or number of products. So it's no different here. So we're going to have, we'll make X our number of t-shirts, and we'll make Y the total cost. Okay? So if X is the number of t-shirts, Y is the total cost, we know it's going to be Y equal to something. So we're going to have Y equals, each shirt costs $4, so that's $4 per shirt, so 4 times X. And our setup fee is $160, so that goes towards our total cost. So now we have our equation. Y equals 4X plus 160. Y is our total cost, and X is our number of t-shirts. Now we got to write an equation for number 2 that represents the income. So this top one, the number 1, was our cost, what we have to pay. Now we're writing a function for the money that we're going to get, the income we have. So the only thing we're told about the income is that we're going to sell the shirt for $8. So there's not going to be a starting point or anything like that. It's literally just going to have Y will still be our total cost, except this time it's total. I'm not going to say cost, I'm going to say total money made, and X is still the number of shirts. This time it's just number of shirts sold. And our equation this time is just Y equals $8 times every shirt we sell. Okay. All right, so that shouldn't have been anything new. We know how to write those equations. We've done that before. But when we've done this before, we've just graphed one or the other, and we've never really solved anything with them. Okay, so that's where we're headed today. So on that same page, it's the same page for you, but for me it's the next page. It says complete the table shown with the cost and the income and then profit. Okay? Well, cost and income, the cost is what we have to pay, the income is what we get. Profit is, are we making money, are we losing money? So it's the difference. So if you go up to the profit here, this profit is the difference or subtraction from the income minus the cost. Okay? So ideally we want the income to be more than the cost, so that's why it comes first. So income minus cost, if our income is more than our cost, we're going to end with a positive number. But if our cost is more than our income and we subtract it, we're going to end up in the negatives, which is what we don't want. We want to make money. We want to have a profit. Okay? So the first one is just defining the variables in the expression. So it says the number of shirts is X. So then the cost and the income, we said those were both Y when we set it up. So these are both Y's in our expression. Okay? And our profit is, like we said, income minus cost. I'm just going to say income minus cost. Okay? All right. So now, when we have sold 0 shirts and we've made 0 shirts, okay? So the cost for 0 shirts is $160. The income for 0 shirts is $0 because we haven't sold any. We haven't made any, so we haven't sold any. And the profit is negative $160. Okay, so now if we go to the cost of making 10 shirts. Well, the cost of making 10 shirts is our starting fee of $160 plus $4 per shirt. If we're making 10 shirts, 10 times 4 is $40, plus 160 gives us a cost of $200. And our income is 8 times the number of shirts we sold. So if we sold 10, 10 times 8 is $80. Well, 200 minus 80 is still in the negative, $120. So we've made a little bit of our money back, but we're still not making a profit. We are still in the hole $120. Now, what I want you to do is fill in the rest of this chart. So remember, for the cost, to find the cost, you take 160 plus X times 4. And for the income, you just take 8 times X. And then for profit, you take income minus cost. So I'm going to give you guys 2 minutes to fill out the rest of the chart. Ready, go. Okay, so now comes the part where we start to kind of solve this thing. So we know how to graph. We practiced graphing yesterday. We've been graphing all year long on Spiral Math and other different assignments. So we know how to graph lines. First thing we got to do is create our labels and our numbers, our intervals. Okay. Well, the nice thing is here, they already give us what we should use as our intervals and how high our graph should go, our upper bound and our lower bound, okay? So our number of long sleeve shirts is our x-axis, and they tell us each interval should be 2.5 and it should go to 50. Well, instead of doing 2.5, 5, 7.5, 10, we might as well just skip 1 each time and just make our labels every 2, but make them 5, 10, 15, 20, 25. So that's what I've done here. So the x-axis, make sure you get them labeled 5, 10, 15, 20. And on the y-axis, it tells us that we should go by an interval of 20 all the way up to 400. So I have done that on the y-axis. So make sure you get that as well, starting at 0 and then 40, 80, 120, 160, all the way up to 400. Okay, I'll give you a second to get those copied down before we start graphing. Okay, so now we need to graph both of these equations. Okay, so our first one I'm going to do is the cost. The cost function, as you recall, is 4x plus 160. So I'm going to go ahead and underline that in red so we can kind of keep track. The cost from now on is going to be in red, the income is going to be in blue. So our first point we can make is our y-intercept. This is already in slope-intercept form. Y equals mx plus b. B's our y-intercept, which is 160 here. So make your first dot at 160 on the y-axis, like I've done there. And instead of going up 4 over 1, up 4 over 1 using slope, I'm going to kind of simplify it. We already know from some of the points in that chart that we filled in before, we already know some of those points. So we know that at 10, if we sell 10, or if we buy 10 shirts, I should say, it's going to cost us $200. So I'm going to put a point there, and I'm also going to put a point at 20 shirts, $240. Okay, we already know those points, so we might as well put them on there. And then we're going to connect those dots and extend our line out like that. Make sure you use a straight edge or a ruler or something so your line is straight and goes through those 3 points that we plotted. Okay, so that is just the cost function. We haven't done anything with the income yet. So now, let's remember, the income is just y equals 8x because it's $8 per shirt. So no y-intercept this time. This is actually a proportionality. So we put our first point at 0, 0, because we know that graph has got to start down there in the left corner. And it's going to be going up 8 over 1. But again, I don't want to have to try to map out up 8 over 1. Instead, I'm just going to choose some points. So if, again, at 10, if we sell 10 shirts, that's 10 times 8, that's 80. So we know there's going to be a point at 1080. So let's put a point at 1080. Let's put a point at 2160. And then we probably have enough points as long as we use a straight edge. Our line's going to be correct. So go ahead, once you've got your 3 points, draw your line. All right, and let's go ahead and label our lines. So label the line that starts at 160, the cost function, and the one that starts at 0, our income, just so we remember. We'll keep track of those things. And then once you're done with your graph, you can turn to the next page. And we're going to answer some questions based on our graph. So, number 5 says, use your graph to answer the questions and describe your reasoning in terms of the graph. So that's why I put this graph back up here. You can flip back in your pages if you need to look back at your graph as we're answering these questions, because we always need to use the graph to answer these questions. Okay? So it says, determine the number of long sleeve t-shirts for which the cost is greater than the income. Okay, so cost is greater than the income. So if we're looking at that graph, we know that the y-axis is our cost or our money, right? So at what point or points on that line or on this graph is the cost function, the cost line, higher than the income? Well, you can tell that from the start, it's starting at 160. So it's starting out way higher, right? The cost is way more than the income. And gradually over time, they're getting closer and closer and closer together. But if we look at this point right here, this is where it kind of switches, and then the income is more than the cost. So at that point, it looks like there's 40 shirts. Okay? So we're going to say for our answer over here for A, determine the number of long sleeve t-shirts, that the cost is greater than the income. Well, the cost is going to be greater from, I'm going to say the cost will be greater from 0 to 39 t-shirts. And the reason that I'm not going to say 40 is because at 40 it looks like they're the exact same. So I don't want to include 40. So the cost will be greater from 0 to 39 t-shirts. Okay. B says determine the number of long sleeve t-shirts for which the income is greater. Well, when the income is greater is when we're past that point, because right here it switches and the income now is greater than the cost. So it's past the dotted green line that the income is greater. So we're going to say at 41 t-shirts sold, at 41 t-shirts sold, that's the point where your income is greater than your cost, but they're not limited to sell 41. They could keep selling them forever and ever. So at 41 t-shirts sold, the income is greater and anything more than 41, it will stay greater. So at 41 t-shirts sold, the income is greater and will be that way for t-shirts sold, for any more t-shirts sold. Stay that way for more than 40. Okay? Anything greater than 40. All right. Determine when the cost is equal. Well, obviously, if the cost is greater at 39 and the income is greater at 41, right in between those is at 40. So at 40 t-shirts, the cost equals the income. And so right at this point where they meet, right in there, okay, where those two lines come together. All right. Now on the next page, there is a little paragraph. So I want you guys to be reading along with me as we go and fill in the blanks when I pause. The point is the point at which two lines cross on a coordinate plane. When one line represents the cost of an item and the other line represents the income from selling that item, the point of intersection is called the point. Good, the break-even point, okay? And it's called the break-even point because that's the point if you sell that number of things. So like in this case, if we sell 40 t-shirts, we say we broke even because we didn't make any money, but we didn't lose any money. That's why we're breaking even. If we sell more than the break-even point, we make money. If we sell less than the break-even point, we lose money. Okay? So 6 says, what is the break-even point for making and selling this t-shirts? Well, that's the same thing as the intersection point, right? Which we already said was 40, because you see that point of intersections right there, and if we just draw a straight line down, it's at 40 shirts. So 40 t-shirts. what is the profit from t-shirts at the break-even point? How much money have you made? Well, according to the income we've made, if you go across here, right here, we've made $320. But wait, we can't say that we made $320. That's just our income. Our cost is also $320. So it's really, at that point, $320 minus $320, and we get 0. So how much profit have we made? $0 at the break-even point. And like I said, that's why we call it a break-even point. What are the costs and income at the break-even point? Now is where, okay, the cost is $320, the income is $320. So yes, when we combine those, it's 0, but we're still bringing in $320 and we're spending $320. So it's $320 for both. And number 9 says, what do the coordinates of the point of intersection mean in terms of the fundraiser? Well, it means the coordinate is 40, 320. So in the context of this, the point 40, 320 means we make no profit from selling 40 t-shirts. State the number of long sleeve t-shirts that must be sold for a profit to be made. We must sell more than 40, so we just write it as we must sell more than, so it can't be equal to 40, more than 40 t-shirts. All right, so again, just to kind of review what we did. We have been writing equations and graphing equations for a lot of the year at different points, okay? So we're already good at that. We have just never graphed 2 equations on the same graph and then compared them like we did just now, okay? But you know how to do all this. You have this example now to reference, okay? And the next page, I guess next 2 pages, 53 and 54, are almost the exact same example, okay? Except you're going to have to read the paragraph closely because some of the costs and the pricing has changed. So what I want you to do now is read through that paragraph at the top of M353, circle the things, the prices, the discounts, all that stuff that's important, okay? And come up with your 2 new equations for 1 and 2, another chart like we did before, and then a graph, okay? So you are fully prepared for this. You can look back in the last few pages or get some help from a partner or a teacher, but I think you guys should be all right, okay? So we're going to give you some time now to work. You're working on pages 53 and 54. All right, you may begin.